In the KTP project, I was actually acting as the WMG supervisor. My role was to make sure that the project went to plan, make sure that Michael had the facilities he needed, and to actively act as the interface between Tildesley's WMG and anybody else that was going to be part of the project. The project has actually achieved demonstration that it is possible to control the properties and the structure of the metal that has been deformed at such a high temperature in comparison to standard day-to-day forging.
I got excited about the position because from the very beginning it seemed to be a great opportunity for my career and personal development.
For the project, I was the academic lead, so this involved training the KTP associate in all the fundamental metallurgical principles, so then he can take that information, disseminate it throughout the company and hopefully make real-world changes. Tildesley as a company are looking to move towards high-value components, looking to produce parts out of materials that other companies stay away from because of how hard they are to form. This project is looking to tackle this on two fronts. The first part is to integrate fundamental metallurgical principles such as recrystallization into their forging process. So this could be advising them on optimal temperatures, die design and processing windows that would allow them to get the most mechanical properties for their current parts. Secondly, we're looking at a novel forging technique called near solidus forging, or NSF. This technology is currently come out of the University of Mondragon in Spain, and we're looking at implementing this at Tildesley.
I help to oversee and resolve manufacturing issues on the shop floor, and I'm also the main facilitator for further collaborative work with academic bodies.
I was responsible for the introduction of the metallurgical knowledge to optimize the conventional forging and to assess the opportunities that near solidus forging could deliver to WHT.
Firstly, we demonstrated the importance of implementing fundamental metallurgy into parts such as bolts, which are really commodity products. For this, we found that there was optimized windows that we can get increased mechanical properties just by changing a few of the core parameters. So from a materials waste point of view, we saved 50% wastage compared to their current processing. In terms of mechanical properties, then we got about 20 to 30% improved mechanical properties by moving to this new technique.
I am full of praise for this collaboration, and I'm keen for WHT to continue using it and gain a competitive edge within the marketplace.
As a result of the KTP experience, I have gained management skills, leadership skills, problem solving or decision making. But I think that most importantly, being able to work simultaneously at the university and at the manufacturing site accelerated my pace of learning significantly.